Okay, for this section, you're going to need the periodic chart. You're also going to need a calculator. So if you don't have it, just pause it right now and we'll get it. Okay, we're going to deal with what we call molecular and molar mass. They are the same thing in numerical values, but totally different in meaning and labels. And so we need to get that distinction in this. A molecular mass is the mass of one molecule. And a molecule is made up of a group of atoms forming one substance. It is also known as a compound. But it's something called a covalent compound, which is something we're going to get in just a couple of chapters down the road. For molar mass, you see the word mole kind of in molar mass. It is the mass of 1 mole of molecules. The numbers are the same, but the label for molecular mass being just made up of atoms and just one molecule with a handful of atoms means the label is going to be for AMUs, atomic mass units. Remember, atomic mass unit simply means either a proton or neutron. So if something has like 18 AMUs, it means it has a total of 18 protons and neutrons of some combination. The molar mass is the mass of 1 mole of that. Well, a mole of any atom on here is the average atomic mass that we find on here, or the mass of a particular isotope. And so that's going to be a mass of 6.02 times 10 to the 23rd of those isotopes, or 6.02 times 10 to the 23rd of those molecules will make up a molar mass. 1 mole of molecules, molar mass. Okay, so the number 6.02 times 10 to the 23rd will not come into play for this because we're dealing with grams on this, which is the average atomic mass. If I was looking for quantity of molecules, then yes, but we are not doing that. This is all about the periodic table. Okay, so we're going to take a look at water. We're going to find the mass of a molecule of water. So we're going to go to this, and water, as you know, is H2O. Now what you may not know is what H2O means, and that's pretty much what this is going to help us out with. This 2 refers to the fact that we have 2 atoms of hydrogen plus 1 atom of oxygen. And so we're going to go to the periodic chart and find hydrogen. And for all of these, I'm going to ask that you round off to 3 significant figures. So don't give me a boku numbers here. Just round off to 3 sig figs. So for this, it says 1.00794. The 3rd significant figure is the 2nd 0. The number next to it is a 7. So that kicks that 0 up to a 1. So this is going to be 1.01 AMUs. And there's 2 of them. So it's going to be 2 times 1.01 AMUs. Plus, now we go over to oxygen. Oxygen is 15.9994. Well, the 3rd significant figure, well, the first one is 1, second one is 5, third one is 9. And the number next to the 9 is another 9. So the 15.9 gets kicked up by 0.1 to become 16.0. So we go 16.0 AMUs. So we'll put that in our calculator, 2 times 1.01 plus 1 times 16.0 if you need to. Most people can do this in your head. This would give you 18.02 AMUs. But that has 4 significant figures because that 0 is actively involved in that measurement. So this becomes 18.0 AMUs. If you want to separate it, you can see it. I generally go like that, and everybody assumes that I know I'm talking about AMUs. That's something as simple as water. Now, a lot of molecules come with, or a lot of compounds and molecules both come with a certain number of parentheses in the formula. So let's do one like that. Let's do calcium nitrate. Calcium nitrate looks like this. Now, you can see here that we got a calcium plus, now, we have a combination of 1 nitrogen, 3 oxygen in parentheses, and then a 2 on the outside. And what that means is that we have inside the parentheses 1 nitrogen plus 3 oxygens, and we add it together, and then we're going to double that entire quantity. Okay? So we go to calcium. Calcium here is 40.078. The second zero is the third secondary figure. The number next to it is a 7. So we kick up that second zero to a 1. So that becomes 40.1 plus nitrogen is 14.0067. The first zero is the third secondary figure. The number next to it is also 0, so it doesn't get rounded up. It stays at 14.0 plus 3 times. And oxygen, as we said, was 16.0 because we got 15.9994, kicks it up to 16.0. And then that whole thing in parentheses gets doubled. So we should have a parenthesis right there. 1 nitrogen, 3 oxygens. Okay? So, this becomes 40.1. Well, actually, you should just go ahead and type this all into your calculator exactly the way it's written right there. 40.1 plus parentheses 14.0 plus 3 times 16.0, close parentheses times 2, gives you an answer of 164 grams when rounded off. You actually did 164.1, but that's 4 secondary figures. The 4 is the third secondary figure. The number next to it is a 1. So we don't round it up, we leave it as it is. And we get an answer of 164 grams. Now, the AMUs, however, for that is the molar mass, the molecular mass is 164.1 or 164 AMUs. Therefore, the molecular mass is 164 grams. That's the difference between the two. This is one molecule right here. This is 6.02 times 10 to the 23rd molecules right there. 1 mole, 1 atom, or 1 molecule. Your homework, find the molecular mass in EMUs and the molar mass in grams of these 5 compounds. Note that this is not carbon and iodine, it is chlorine. So be careful of that. Okay? Good luck.